Hello everyone and welcome back. So in this video I wanted to share a technique with you, or a few techniques on how to add details to your height fields, where you might want to create some cliffs or mountains and add some life to it. So basically I'm starting with an height field. These are some of the techniques I shared on Patreon on my last post. There's a 1-hour video tutorial on there that you can watch, but I'm going to break it down for you in a few minutes. So I'm starting with a night field, then I'm drawing a mask. I went through a few iterations and subtracted some shapes and whatnot. Then I'm blending two masks, one slightly blurred, then remapping, so I blurred one so I can have this transition in the bottom. Then I'm adding some noises. I'm not so sure about these wavy effects, but it's there, so I won't change it now. Then I'm adding some distortion, blurring a bit the details, clearing the mask. Then I'm creating a mask for the slope, where I will be adding the side details. As you can see, I'm using a copy layer to save it in the slope layer. Then I'm blurring quite a bit the side details, so I don't get too much distortion as in an input. Converting the height fields, and as you can see, this sort of geometry stretched out polygons won't give us a good result when using the Triplaner Note, which is what we're going to use to add some details. So I'm remeshing everything after a clip, and we should have something like this. I ended up adding a few iterations to remove some clusters of geometry. As you can see, we still have some of it. Then the more geometry you have as an input before the triplaner, the better the results will be, or at least until some point. So in this case I'm subdividing 3 times. Let's just place one to be a bit faster and we can see the result. So this is one subdivision, and here are 3 subdivisions, quite a bit more detail, but also very high poly. But this is the result I ended up using as an input to create the height map, the displacement map. So let's say we just have one level and we're using the triplanar displace. I believe I shared before this technique. We're using the triplanar displace in the color inputs, not the displacement. And I'm using 1, 2 and 3. These are just Megascans assets. Then I'm also blurring the normals, creating point normals and blurring. And it's important you do it after the triplanar displace, otherwise the triplanar displace won't update the normals, or you will lose the normals after the triplanar displace, so do it after. And so we have this result, and in the point VOP I'm just compositing the different triplanars. In this case you import the second and the third input with the import point attributes and importing the CD, and I'm just compositing with an overlay mode. and maybe we can reduce some of the alpha of the different textures. And I'm compositing the first two, then adding the third. As you can see, I'm reducing the alpha of the third texture, converting it to a float, fitting the range between -0.5 and 0.5, because the zero value of the Megascans textures are 0.5, multiplying by the slope, and displacing quite a bit, because this is a large model, as you can see. So we need to displace it quite a bit, and just adding a constant to the color, otherwise we have the triplanar color. So after that, as you can see, this is with 3 subdivisions. We have, I believe, enough detail, and we have it all the way around. And one thing you should play with is the offsets of the textures. This will give you slightly different results. If I just use the first one, let's connect the CD to the vector to float. As you can see, this particular texture acts as a overall detail, overall shape forming, let's say, and from there you can add more detailed ones, more high frequency textures, and you can also add procedural noises. I just found that these sort of textures give you better results and it's faster. So with 3 levels of subdivisions you get this, and after that you have the high poly completed. Now you need to create some UVs and low poly geometry, and the way I'm doing that, I'm not sure if it's the best option, but I'm reducing the polygons, remeshing, and then create instant meshes. And this will give me a result which looks something like this, which is pretty clean and works well as a low poly. And after that we create the UVs. And the reason I'm doing these 3 operations in this particular order is because after the high poly, this is a very dense mesh. If you try to remesh this, it will be really slow. So it's just an optimization. And I'm also reducing and remeshing within a loop. So let's see. Let's set to manual. And I'm creating a scatter. I'm scattering some points and creating an attribute to be on some islands. So the mesh is divided into different islands. And then I'm reducing in a loop. In this case it's compiled. Again, I go more into detail and do it step by step on my Patreon video. You can check that out. But it should be easy to see the result if we check the file cache. So as you can see, we have these lines that are the different islands that we're splitting the geometry into. So we're remeshing by iterations instead of, we're reducing by iterations instead of reducing all at once. That would be really slow. And after the poly reduce, I am remeshing. And the reason I am remeshing is to give a cleaner input to the instant meshes, otherwise it wouldn't work. This is a very picky node, sometimes just doesn't want to collaborate. So I'm remeshing again with the same workflow. So dividing the mesh into small islands with an attribute, and then doing the remesh. You can take a look at the file and you explore on your own. So after I do instant meshes, 40k polygons, and also do a smooth. Actually, it was pretty fast to calculate this. So I also do a smooth just to have a cleaner input. And then I'm caching, and this is our base mesh without UVs. And after that I am creating the UVs, and again let me show you this time how it works. I'm creating an attribute called divider, and just divides the mesh into different sections, different islands. And then I'm promoting to primitive and iterating over and creating a UV flatten. So this should give you something like this. It doesn't look very promising. Then you can do a UV layout and you get the different islands. Again, this is just a way to do it quickly and without worrying too much about UVs, as we will be using Triplaner to, as I was saying, we will be using Triplaner projections to create the textures inside Substance. So then I am caching this and softening the normals so we don't get any errors on Substance side. And I'm also creating a slope attribute just for the scattering of the grass that I will be adding later. In this case I want to output it as an attribute. And saving the low poly geometry. And then in the maps baker I can just set up the height channel as an EXR, set your resolution, and it's important to set the correct distance, and so we can actually visualize the distance. And in this case I have set it to 4. This is quite a big mesh. I also noticed that if you add a subdivide with 1 or 2 iterations, it also helps to give you a better result in the height map or displacement map. So this is really simple, just set your distance according to the detail in the high poly, and you are good to go. Just press render. Then you can go to the composite view, and as you can see, let me just show you something. This is the first version, and if I disable this, equalize, as you can see, we have some problems here. So the distance was not enough. I believe I set it to 2 at first, and as you can see we have some holes, which is not visible when you equalize it. Sorry, this is not visible here, at least not so noticeable. So although it's good to see the equalized version to check if everything is working, it's also important to have a look at the raw input so you can debug these little errors. So this is the second version. As you can see, there are still some parts where it has some problems, but overall it's much better. And you can eliminate those by increasing the distance. So this is the height map. And we can just go to OBJ and scene view, and let's go to Solaris, stage, and let me just give you an example. Here I have some snapshots. So let me see, this is the raw geometry, the low poly geometry. This is the first one, so it doesn't matter. So this is the displacement map working, and this is the high poly rendered. So I just brought in the 4 million polygons, or 7 million polygons I believe, geometry, and this is the render, and then this is with displacements. So just the base mesh, the low poly with displacement, so very similar. And this is pretty easy to set up. You just create a material X image, set it to float, create a displacement. In this case I am reducing a bit, but if you leave it at 1 it will give you the exact result. And then just create a surface material and connect your standard to the surface shader and the displacement to the displacement shader. And that's basically it. I can show you a small render of it. So this is a test render I did with some grass and with all the textures and whatnot. I'm still going to show you the substance parts, not the texturing itself, but the workflow, let's say. So this is an example render. I'm also adding some clouds and some grass, and you can play with the render geometry settings with the amount of dicing quality, but 1 should be pretty good. Maybe it's a bit even overkill. And yeah, let's see in substance. Let's see the other part of the graph first. So let's see OBJ. So I have shown this part, and in here I'm doing the same, but the same concept of dividing the geometry into sections and iterating over it, because I want to export the high poly to use in Substance to bake the maps, and I don't want to render just one file. It just will be too big to load in Substance and to have on disk. It will be just too heavy. So I'm creating a loop, and with the Python, I believe I shared this tip before and I saw it somewhere too. So I'm just executing the wrap geometry by using the press button function, and in the wrap geometry I'm using the iterate detail attribute, the iteration detail attribute, to rename the pieces or to name the pieces. And yeah, the Python here does everything. Then you execute the loop and check this node, render these nodes, and it will automatically export each part to a file. So here I am in Substance Painter, where I did really basic texturing techniques, just using some textures and smart masks mask editor to create some details, some blending between the different textures. I believe I used 3 textures. So there's one. Then added some in the occluded areas, added the grass with, I believe, the, let's see, the world normal, yeah, world space normal. And that's basically it. Very simple setup. And the most important thing here I wanted to show you is the baking process. So you select the maps you want to bake, import your, in this case I have 32 pieces of the high poly. You can have less or more depending on the amount of polygons you have to start with. Set your resolution and just hit bake. Make sure your bounds are looking okay and you can just press bake. And you should have a pretty good bake. In this case, let me see, mesh maps. We have the normal from the high poly, the curvature, the AO, as you can see, thickness, and so on. So yeah, that's basically everything I wanted to share with you today. If you want to investigate on your own, you can check the file on my Patreon, and I also have a lesson there with over 1 hour where I go through step by step, not this project but a similar one with the same workflow, and you can check that out if you want. Other than that, thank you for watching and see you in the next one.